Namaste dear students. Do you think a flower can differentiate between soap and vinegar? Well, let's find out. Rather than opening a bottle of indicator, let us dive into nature and prepare our very own natural indicators. But before we do that, did you know indicators were discovered by accident? In the 1660s, a scientist named Robert Boyle dropped nitric acid on a purple colored plant extract. The plant extract instantly turned pink. This led Boyle test dozens of solutions, which led to a discovery that plant extracts interact with acids and bases differently. Even the litmus indicator that we so frequently use in our labs has been derived from a slowly moss-like growing organism called lichen and has been used since the last 700 years. So today, we aren't just doing chemistry, we are repeating the oldest tradition. Let's see, how did our students prepare those natural indicators? The natural indicators were prepared by crushing fresh periwinkle flowers, by chopping and boiling beetroot as well as turmeric to extract the anthocyanin pigments from it. These anthocyanin pigments undergo certain structural changes on interaction with acids and bases. These structural changes are the reason because of the color shift that we're going to observe ahead. After preparing the indicators, we tested every indicator across the pH scale, starting from 1 being highly acidic to 14 being highly basic. And we didn't just stop there. We compared our natural indicators with the lab favorite synthetic indicators like phenolphthalein, methyl orange, and universal indicator, which by the way is a mixture of multiple indicators in one single bottle. These indicators were placed drop by drop on a pre-prepared sheet which had a pH range starting from 1 to 14. And then the magic began. Drop by drop, the colors came alive. Some barely changing the color, quietly signaling the solution is neutral. Some turning into bright pinks and purples and blues. Because every shade was a clue, quietly signaling if a solution was mildly acidic, mildly basic, highly basic, or neutral. We also got to know not all indicators react with acids, not all react with bases. Some only react with acids while some only react with bases. Whereas certain indicators like universal indicators reveal the whole pH spectrum. You might be wondering, does this matter outside the classroom? Well, definitely yes. These indicators are used by healthcare providers, scientists and researchers, as well as the fashion industry. The NASA scientists working on the Mars mission use highly advanced sensitive pH sensors, which by the way work on the same principle, to test the soil on Mars, searching for clues if the planet could ever support life. The healthcare workers in the ancient time have been using the same natural indicators to test all the bodily fluids to give you an idea about your overall health. The doctors today use pH strips to identify acidosis, kidney issues, and infections almost instantly. Years before our healthcare providers and the Mars mission, our farmers used the same indicators to test if their soil would grow certain crops well or not. The fashion industry uses precision pH scale to maintain the fabric color consistency on a huge industrial scale. So the color changing drops you saw us making today connect us from scientists from thousands of years ago to cutting-edge researchers working on Mars missions right now. But this activity wasn't just about making colorful dots. It was about asking questions, making predictions, deriving scientific outcomes, and learning a little more about chemistry. So the next time you see a flower in your garden, remember, it's not just blooming, it's doing some chemistry on its own.